We'll proceed in vector algebra and calculus. Vector algebra and calculus. That is something that is considered as the most difficult thing in mathematics, and it is considered as the most complete thing in mathematics. Most difficult thing in mathematics and most complete thing in mathematics. After all, completion comes with the difficulty one. Completion never comes with the easy path. And why we say that vector is completion of mathematics is because it has direction. At the end, everyone needs the direction. If someone is saying that I have traveled 2000 kilometers this this month, this month I have traveled 2000 kilometers. Someone would certainly ask from where to where. From where to where means direction is important. Okay, in that sense, the vector has direction also. Okay, so that is the scenario. Now we are talking about work done. We are talking about work done. How we calculate the work done? Work done is force into displacement. Force into displacement is called work done. If this is the force and this is the displacement direction, like I have taken example of a car is moving in this direction. This is x-axis, this is y-axis, this is force direction, this is force direction, this is x-axis, and this is y-axis. Okay, now if this is force, then if this is wind, this is what we are talking. If this is wind direction and car is moving from origin, this is origin. If this is origin, then this is y-axis, this is x-axis. Car is moving along x-axis. There is a wind that is flowing like this. Okay, wind is blowing like this. Now I have taken this as rotation of xy plane. Actually, this is x-axis and this is y-axis. This is z-axis. So on ground, car is moving along x-axis and wind is moving along x and y, 45 degree from x-axis. Now I have rotated this like this. So this is y-axis, this is x-axis. Wind is flowing in this direction. Okay, if that is the scenario, wind is blowing in this direction, then how much work is done, how much energy? The concept is energy. How much energy car is receiving from the wind? That is this wind force cos theta. Wind force cos theta. That is the force car is receiving from the wind. That force into x, that much is the energy it received from the wind. If wind is blowing exactly in the direction of car, then energy received by the car when it moves 0 to x, that is more. If wind is blowing in exactly perpendicular to the car movement, then wind force cos theta 90 0 means car is moving 0 to x because of its fuel energy only. Not it is not getting any assistance from the wind. Okay, so that is the scenario that we are looking. How to calculate how much energy car is receiving when it is under the wind. That is the question. That is the answer. What we did is we went for wind is blowing in a direction. So consider the wind force is capital F. Now I can denote capital F as vector capital F. Capital F, on top of it vector sign, arrow sign. If capital F is there and on top of it there is a vector sign, then it is considered as force vector. Force vector means wind has a magnitude and it has a direction. So rather than saying this is the magnitude, this is the direction, I can just represent as capital F, on top of it arrow mark. How a vector is represented is addition of orthogonal components. Orthogonal components means independent components. They are 90 degree to each other. Internally, they may be dependent on each other. Like we are saying that capital F, the force vector of a wind is xi plus yj. Xi plus yj. At the origin, what is the wind force? Xi plus yj, 0. At the origin, wind, there is no wind at all. But as we move along x-axis, as we move along y-axis, wind is gaining strength. Xi plus yj. Along x-axis it is xi. Along y-axis it is yj because x is 0. And along any other angle it has the other. Consider it is wind is passing through a point called 2 comma 1. Then it is 2i plus 1j. Okay, when someone is standing at point 2 comma 1, how much wind strength he is feeling? Then it is 2i plus j. For 2 square plus 1 square root. The square root of 5 is the power of the wind that he is experiencing at point 2 comma 1. Makes sense, right? If someone is standing at point 10 comma 5, how much power of the wind he is experiencing? Then it is 10 square plus 5 square root, that one. So as someone is going beyond origin, far he is going from the origin, more power of the wind he is receiving. In that sense, the car, when his car is moving from origin to distance x on x axis, then here car is moving only because of the fuel. But as car is proceeding, it starts receiving energy from the wind as per the wind vector. What we have learned till now is that what we know, if you ask any kid, okay, you tell me what is the energy that car is receiving from the wind? What is the displacement vector of the car? Consider the displacement vector is d vector. Then f vector dot d vector is the energy car is receiving from the wind. Everyone knows that force vector dot displacement vector, force vector dot displacement vector is the energy of work done, is the energy car is receiving from the wind. Okay, but here the force vector of the wind is algebraic vector. It is not constant vector. When wind is at 2 comma 1 point, at that point the force of the wind is 2i plus 3j. When wind is at 0 comma 3, then wind is 3j. When wind is at 4 comma 0, then it is 4i. But at every point on xy plane, wind strength and direction is different. But everything we taught in vector, the vector representation is addition of orthogonal components. This is how vector is represented: 2i plus j, xi plus yj, xi plus yj, yi plus xj. No problem. Yi plus xj. Okay, so if this is called vector field or algebraic vector. Algebraic vector has components: x component, y component, I component, its strength. If there is an energy vector, what is its strength along x-axis? What is its strength along y-axis? Just add it. That is the new vector. Hope. This is what many times we have demonstrated. If this is the origin and there is one energy coming to origin from minus x, if this is origin, one energy is coming from the minus y hitting the origin. If they combine together, wherever they go, that representation is addition of these two vectors. So vector, any vector is represented as addition of its component along the orthogonal axis. Okay, if I say I minus 2j, actually it is addition only. I plus minus 2j. I plus 2, 2 into minus j, means there is one I vector and 2 into minus j. If this is j vector, going along y direction is j vector. Going in along minus y direction is minus j vector. I minus 2j, I plus 2 into minus j. That is true. Okay, so there is nothing called negative in vector. Very few people they know that there is no negative in vector. I have seen in the book, internet, everywhere. What is I minus j? I minus j is this vector. What is I plus j? I plus j is this vector. Wrong. There is nothing negative in the vector. Everything is positive only. If I is east, then west is minus I. Now I don't need to represent west as some vector as alpha. East is I, then west is alpha. No. East is I, then opposite direction is west minus I. If north is J, then south is minus J. This is vector notation. Okay, if that is this is the case, then what we have seen, that is unprecedented. Whatever we have seen, that is unprecedented. Unprecedented in the sense that if this is the vector field, if this is the force field, and I want force field, there is a car that is moving along this line. Car is moving from here to here. Car is moving from this point to this point. Now, this is x-axis and this is y-axis. Okay, car is moving like this. If this is y-axis, this point is 0 comma 3. If this is x-axis, this point is 3 comma 0. A car is moving from 0 comma 3 to 3 comma 0. There is a force vector, wind, that is blowing in direction of xi plus yj. Okay, now you understand how xi plus yj is. How much energy car is receiving when it is coming from 0 comma 3 to 3 comma 0. Okay, or I would rephrase it. Okay, let me proceed with it. Then we will see that also. Okay, what is the energy car is seeing when it is going from 0 comma 3 to 3 comma 0? Anyone would say force vector dot displacement vector is the work done. That's what energy it is receiving. Then I have to find the displacement vector along this line, the vector representation of this line. How we find vector representation of line? We have seen in the past video that vector representation of any line, vector representation of any line is differentiation of position vector. What is position vector? If I take any point on this line at x comma y, if I take, if this is x-axis, this is y-axis. This is the line along which car is moving. If I take any point here x comma y, from origin, if I connect this point, this is called position vector of x comma y. If I differentiate this position vector, whatever vector I receive, that vector is tangential at the point. Tangential at the point. So at this point, if I talk about tangential line, that is the line exactly along the line. So if I have x, I have proved it. We have proved it that y a position vector. If I differentiate a position vector, then how come it becomes tangential at any point? That is a big thing, right? You take any curve, take circle. At this point, what is the tangential vector equation? At this point, x comma y. Tangential vector means tangent line. If I know tangent line equation, then I can find the tangential vector equation. This is how we proved it. So, what is the tangential equation at this line? Of this tangential equation of this line, tangent at this point, or tangential vector, or curve vector. This is also called curve vector, displacement vector, tangent line, tangential vector, whatever comes to mind. Okay, every point tangential vector is different. If it is a curve, if it is a sinusoidal curve, if it is a sinusoidal curve, this is sinusoidal curve. Okay. This is a sinusoidal curve. This is origin, then maximum, then touching the x-axis again, minimum. Okay, at any point, what is the curve vector? At any point, what is the curve vector? That is a tangential vector. If this is a line, what is the curve vector? Curve vector at any point that is tangential line, that is along the line. But for curve, it is tangent at that point. Anything, it is tangent everywhere, right? Here also it is tangent, but tangent is along the line. Here also tangent is along the line only at that moment if you see. Because line is a curve, right? It is changing everywhere. But that moment where it is tangent, it is exactly in that direction. If you see the collection of a vector, tangent vector, if you see, just I am saying like this is a tangential vector. Then anyone would imagine that it is a curve is like this. So tangent vector is along the curve only. What is your tangential vector? This is my tangential vector. It is going in a straight line. Looks like the line it represents this vector, this line it represents is a straight line. My tangential vector is like this. Means the vector, the tangential vector, displacement vector, it is representing a line that is a curve. So we have seen that if I take a position vector and differentiate it, then the new vector that comes in, that is the curve vector, displacement vector, tangential vector. Okay, if that is the case, then why we go for integration? We are trying to find the, if there is a wind that is blowing in direction xi plus yj, this is x-axis, this is y-axis, this is x-axis, this is y-axis. In that case, car is moving like this. If and force is like this, x plus y. Force is everywhere it is different. X plus y, xi plus yj. Now when car is moving from here to here, in that sense, I take any point here as position vector, xi plus yj. What is the work done? Work done is the force vector multiplied by the displacement vector. What is the displacement vector? Displacement vector is differentiation of position vector. This is what we saw. Okay, then work done is force dot d of displacement vector, d of position vector. Okay, because work done is force vector dot displacement vector is the work done. Force vector dot d of the position vector. Why you are talking this much? I know what is position vector. Why I know the displacement vector. What is that? The line you are talking that it is intercepting y-axis at 0 comma 3, intercepting x at 3 comma 0. That line is I minus j. I know that. You are talking about vector, right? That line is I minus j. Now calculate the I minus j where I component is 1. I multiplied by 1. I x component is 1. So force vector is xi plus yj dot I minus j. If you do dot product, it becomes I minus x minus y. That is the work done. Multiplied by x, 0 to x you are saying, right? Or 0 to 3. 0 to x multiplied by x, because I minus j, the ith is the x component, its value is x. Sorry, its value along x-axis is 1. If I want along x-axis the movement, car is moving like this. Along x-axis it is moving 0 to x, then multiply by x. Right now it is xi plus yj dot product I minus j. It resolves in x minus y multiplied by x. That is the work done wrong. This is what we are saying. We are trying to, if someone is saying like this, that the x component of the displacement vector, that is I minus j, is 1, get the work done, multiply it by x. It is same as xi plus yj dot I minus j full multiply by x. It is same as xi plus yj dot xi minus xj. If that is the case, then there is dependent and independent component. I'm sorry, the displacement vector along 0 to x, if we are saying, displacement vector is considered as independent component, and force vector, that is xi plus yj, that is considered a dependent component. If you multiply dependent and dependent component, it cannot be direct algebraic multiplication. This is calculus. If x and x are independent to each other, then x into x is x square. But one is independent and one is dependent on it, then x into x is not x square, it is x square by 2. because it will be resolved as x into dx, integration from 0 to x. If you are multiplying two items when one is independent and one is dependent, you cannot multiply directly. This is the summary of calculus. From here only calculus begins. Okay, then if I want force into displacement, then it cannot be direct multiplication if force is algebraic vector. Okay, in that sense, it will resolve into calculus. If that is the case, then better get the displacement vector through the position vector only. Okay, in that sense, what is the position vector? Differentiate it and get the displacement vector, and then do the dot product and integrate along the x-axis. This is what we have seen. So between xi plus yj, d of position vector, that is xi plus yj again. If that is the case, then it resolves into x dx plus y dy. What is y? Along the line we are trying to calculate the energy, right? So line equation will take the priority. So x plus y equal to 3 is the equation of the line that is connecting 3 comma 0 and 0 comma 3. If that is the case, y equal to 3 minus x dx plus 3 minus x d of 3 minus x. It becomes 3 minus x d of minus x. 3 is gone. Now 3 minus x d of minus x. It becomes 3 minus, okay, it becomes minus 3 dx plus 3 dx. Here already we have x dx plus x dx plus x dx minus 3. Okay, then 2x square by 2. X dx is x square by 2. 2x square by 2. X square. X square minus 3x. From distance 0 to 3, then x square minus 3x. If I take 3 square minus 3x, 3 square minus 3 into 3, 99000. No work. No work done. Okay, someone would say, are you kidding? That if wind is blowing in x plus y direction and car is moving from here, how come wind would not suffer? It looks like wind is exactly perpendicular to this line everywhere, or whatever it is, something like that. Here it is not perpendicular, here is not perpendicular, but whatever it is, this is how it is. X dx plus y dy. This is normal integration. Y is 3 minus x. D of y 3 minus x. 3 minus x d of y is minus dx. 3 minus x minus 3 dx. Then x dx plus x dx minus 3 dx. Then it becomes 2x square by 2, x square minus 3x. Okay, if you substitute it with 0 to 3, that is x, 3, 3, 0, 0. No work. So car is moving from 0 to 0 comma 3 to 3 comma 0. On xy plane, there is no work done. There is no work done from no energy it is receiving from the wind somehow. Okay, if wind is xi plus xj, if wind is yi plus xj, consider this. Now, yi plus xj, if that is the case, then yi plus xj, if I am at x point 3 comma 0, then it is y is 0, xj, 3j. Wind is in this direction. If it is along y-axis, if I take this, then it is along I direction. It is like this. Wind is very different now. Yi plus xj. This is algebraic vector. Now let's do it. I've never tried. So it becomes y dx plus x dy. Yi plus x dx dot product with d of xi plus yj. So it becomes yi dot dxi plus xj dot d of yj. It becomes y dx plus x dy. Y is 3 minus x. 3 minus x dx plus x into 3 minus d of 3 minus x. So 3 minus x, it is x dy, right? I'm sorry, y dx, 3 minus x dx, 3 dx minus x dx, that is x into minus dx minus x dx. Here 3 minus x dx, there it is minus x dx, 3 minus 2x dx, 3x minus x square, that is the work done. 3x minus x square, that is the work done. Then 3, 0 to 3, 9 minus 9, 0. No work done. Then also. What about xi plus xj? Xi plus xj. Now someone can imagine what would be the force vector. Now it is x dx plus x dy. If that is the case, then x dx plus x into minus x into minus dx, again x dx minus x dx, again there only it is 0, no work done. Amazing, right? Anyway, someone can try other thing also. Consider it is force is xi, only in x direction force is. Then what about it? Then it is x dx, and there is no j term. X dx, x square by 2. Now energy, car would receive energy from the wind. If wind is blowing in x direction, if wind is blowing in y direction, then it is yj. Now x is gone, y dy, y dy. Y is 3 minus x, and it is d minus x. Then it is x dx minus x dx minus 3x, 3 dx. That is x square by 2 minus 3x, x square by 2 minus 3x. Now 0 to 3, then it becomes 4.5 minus 9, and then 0, minus 4.5. If wind is blowing in this direction, then car is receiving energy, but it is negative. Means wind is opposing the car. If car is moving from here to here, if car is moving from here to here and wind is blowing in along x-axis, then it is receiving energy from the wind. Okay, that is should be considered as case study. Now, the question that is arising here, we are taking this vector very serious. It is understood that we are taking vector very serious. Now, can someone proceed in this direction as another variation? Another variation, something called parameterization in the vector. Parameterization in the vector. Right now, we have two variables, x comma y. Can we think about only one variable, that is t? Right now, vector is vector. If I take position vector, that is represented as p. P of x, someone can say x comma y. P of x comma fx. That is the vector. Any point is x comma y. Any point is x comma y. Okay, where x is independent and another is function over x. That is p vector in bracket x comma fx. Can I represent with one component only? This is called parameterization. T. There p will be replaced by r. This is called parameterized vector. R as function of t only. Is it really possible that we can represent the two-dimensional curve in t only, in only one independent component? Is it really possible? That is the question. Okay, consider a circle. Consider a circle, and car is moving from here to here. This is x-axis. If this is x-axis, this is origin. If this is origin, the circle is centered at the origin. The circle is centered at the origin. If circle is centered at the origin, from the origin, if I go up, exactly from here, car is moving like this from 0 to A, or car is moving from 0 to X anywhere. If that is the case, then what is the work done? Let's find the position vector. We know that work done is force vector dot d of position vector. This much I know. Consider what is the position vector. What is the equation of the circle? That is x square plus y square equal to a square. If I consider x equal to a cos t, x equal to a cos t, a is constant, that is a circle, that is the radius of the circle. T is constant, t is the angle. Okay, x is a cos t. Then y equal to square root of a square minus x square. That will be resolved as a sin t. Now we have only one independent component, that is t. A is constant. This is called parameterization. X equal to a cos t. Now x is a function of t. Y is function of t. If that is the case, then anywhere, this is the point P, that is point in x comma y, and from center if I draw a line, this is position vector, that is xi plus yj. No, because a cos t, it is now a cos t I plus a sin t j, where this vector is represented as r small bracket t bracket closed, r t. This is called parameterized vector. If that is the case, then what is the work done when car is moving from here to here? What is force vector? Consider force vector is xi plus yj. Force vector is a cos t I plus a sin t j dot with d of a cos t I plus a sin t j, because that is also xi plus yj. If that is the case, d of this will become a minus sin ti plus a cos tj. Okay, now do dot product of these two. There minus a cos t sin t plus a sin t cos t. 0 again. So work done by the vector xi plus yj along the line, along the line, any line, it resolves in 0. No work done, because the force vector we are talking, it is radial. If it is radial, then along the curve line, the work done will be 0, because every moment this is perpendicular to the curve. Now, let's proceed. Let's consider the force is xi plus xj. What is the case now? A cos ti plus a sin tj. Dot product, dot product of d of a cos ti plus a sin t. I'm sorry. Force is xi plus xj. A cos ti plus a cos tj. D of position vector, that is a cos ti plus a sin tj. D means differentiation. A minus a sin ti plus a cos tj dot product. Now it becomes a cos minus minus a square minus a square minus a square cos t sin t minus a square cos t sin t plus a square cos a square cos t cos t. Okay, a square I can take out. Now it is minus cos t sin t plus cos square t. Okay, dt. This is what I have to integrate now to get the work done for the force is xi plus xj. Okay, that is minus cos t sin t plus cos square t. Okay, I really don't know what it is. Minus cos t sin t. What is the integration of this? Someone can calculate. I believe integration by part would work. Cos t sin t, if someone integrate, that is cos t and integration of time sin t. Okay, then it becomes integration of sin t is minus cos t, minus cos square t, minus cos square t, minus, and then differentiation of cos t, that is minus sin t. Integration of sin t is minus cos t, minus minus gone. Now again it is cos t sin t minus, if I take it this side, then it becomes 2 into integration of cos t sin t equal to minus cos square t. Then integration of cos t sin t is cos square t minus cos square t by 2. Now I can replace here, we have minus cos t sin t means plus cos square t by 2 dt plus cos square t dt. If that is the case, I believe it becomes 3 by 2. 3 by 2 I can keep outside. Outside a square is already waiting. 3a square by 2. And now integration of cos square t dt. So someone can find integration of cos square t dt and integration from 0 to x, if I say 0 to a, 0 to a. Then what is t? Okay, x equal to a cos t. When x is 0, then cos t is 0, means t equal to pi by 2. When x is a, cos t is 1, when t equal to 0, pi by 2 to 0, that is t, pi by 2 to 0, that is t, and then cos square t dt. Okay, I believe it. I don't know, but it would be known that what is integration of. Now it is simple, right? But everything came in one independent variable t only. No need to set y and this and that. So someone can proceed through parameterization, calculating the work done. We will proceed on this, and I'm not running away. We will proceed on this, calculating the energy by the force vector along a displacement. But it talks many stories, not only one. So that we will see. Please do support us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.